Okay, well, look what just arrived. This is a DART. This is a high efficiency laptop, ultra small laptop notebook power adapter, 65 watts. Actually the lead detaches. This thing plugs straight into a power strip. So say you don't have the AC lead that you normally have with the laptop power adapter. Actually really impressive. Size wise it fits in your fist. The cable here has this neat USB thing on the end, midline on the cable, so that you can use USB, plug that back in. It's a power adapter. So, big question, is this as good as claimed? Is this really a high efficiency power adapter? So, the goal here is to find out, actually get some measurements on it. So what I have here is an electronic load. This is a bench electronic load. I have a temperature chamber. This thing's warming up right now. You can see that there's a appliance bulb in there. That's why it's so bright. Hopefully it'll turn off shortly. That's warming things up. The chamber is a oh, there it goes. Okay. The chamber is a thermoelectric wine cooler. So when it gets too hot, it cools things down. When it gets too cold, the bulb turns on. I can show you on the side here. Somewhere here. There we go. You can see it is at 25.2 Celsius. So we're trying to keep things at 25 Celsius. It's set up to have airflow around the chamber, but not forced directly over the device. So there's a little bit of self-heating from the device that we're not forcing air directly over it, but there is convection. There's a fan forced at the bottom to get airflow through the chamber. So give me a moment to set things up. Plug that in. We have 110 volt inside the chamber. And, oops, that one. This one. The cable. So I'm running the DC cable outside the chamber. There, that's not. Make sure there's airflow around it. That looks good. And I'm going to plug this into the electronic load. Okay, the other piece to this is we have a kilowatt meter. This will do, it measures to a watt, it doesn't have a decimal point, so we'll keep that in mind. Plug that in. Set it to watts, 0.0, 0, that's good. Okay, so under no load, this thing is reading 20.47 volts. So it's doing a really good job of regulating. Right, so this thing's doing a really good job of regulating no load voltage. So let's give it a load. Power. It's a 65 watt power adapter, so let's try 50% load. Let's run it at, 32.5 watts. 32.3, 34.4, 32.5, okay. Okay, nothing exciting happened. We are at 20, turn it on. There we go. We are at 20.19 volts. So it's doing a really good job of regulating voltage. And our watt meter, I'll show you that, is at 34 watts. So you see that? Yeah, 34 watts in. 34 watts in, you get 32.5 watts out. That's impressive. Okay, well let's push this a little harder. Let's see what it can do under that heavy load. Let's go to 60 watts first. Make sure it can do that. Okay, there we have 60 watts. Everything's ticking along quite happily. We are reading 19.73 volts. That's working. Now, 65 watts. We'll point out that to get 65 watts at the load, this is down a cable. This is the cable that came with the power adapter. The power adapter actually has to generate a little bit more than 65 watts because we're going to have a little bit of loss through the cable and a little bit of loss through this connector on the end. So let's see if it will do 65 watts. Okay, that's 65 watts. I'm reading 19.64 volts. And if we look at our watt meter, see that there, we're reading 69 watts. So that is 69 watts in to get 65 watts out. I need a calculator for that. Let's double check. Okay, so we are 65 enter, 69 divided by, we are 94% efficient. Wow. Okay, and that is impressive. A power adapter is considered high efficiency when it hits 80%. So when you get anything you've seen online for looking at power adapters, usually 80%. That's the big number that everyone's trying to hit as being considered a high efficiency power adapter. When you get to, well, it's getting hot. 90% efficiency is possible. I've seen power supplies advertised at 90%. That's kind of the upper limit of where things are at. This thing's doing 94% efficiency. It's stable, it's 65 watt, 19.63 volts. We are stable at 69 watts. Temperature is stable at 24.8 degrees Celsius. This thing's the real deal. This thing really is a ultra high efficiency power adapter. I'm quite impressed. So accuracy of this test. The electronic load should be pretty good. This is a bench electronic load. Temperature chamber is keeping things stable, pretty close to 25 Celsius. We're at 24.8, according to the temperature sensor at the back of the chamber. So that's doing well. Ideally, I'd like to have another decimal point to the watt meter on the input. So we could easily be out by 0.5% because of that. So if we get enough comments or complaints, I'll see if I can track down a bench watt meter and see if we can get a higher resolution on the input. But yeah, that's the dart. I'm impressed. I'll be using this myself. Yeah, well, thanks for watching, and feel free to post comments.